This video is on section 7.3 notes, annuities. So we're going to look at how to calculate annuities. And before we do that, let's define some words. So first, an annuity is an interest-bearing account into which a series of payments of the same size are made. So before, we've been calculating interest and things like that, but we've been talking about accounts where money was put into the account and then sits there. So here in annuities, money's going into accounts, but a series of payments are being made into the account to kind of help that account grow. An ordinary annuity is an annuity in which one payment is made the end of every compounding period. So if money is compounded monthly, then it's the end of every month. If it's compounded quarterly, it's the end of every 3 months. The future value of an annuity is the amount in the account, including interest, after all the payments are made. So here's an example problem. It says, suppose that in January, you begin making payments of $100 at the end of each month into an account paying 12% yearly interest compounded monthly. How much money will be in this account for a summer vacation beginning on July 1st? Okay, so if you put $100 into the account in January, then that $100 has February, March, April, May, and June to accrue interest. So 1, 2, 3, 4, it has 5 months to accrue interest. And the interest that it's going to accrue is 1/12, 1 month's worth. Each month it's going to have 1 month's worth, 1/12 of 12%. So I'm going to take the 12% and I'm going to divide it by 12, and 12% divided by 12 is 0.01. So each month that $100 can earn 1% of interest. Okay, and it's going to do that for 5 months. So I'm going to say we'll keep 100% of the 100% of the amount, $100, 100% of that plus 1% interest is 1.01. Okay, so if I want to calculate that for 5 months, I'm going to say that $100 that was deposited in January is going to become $105.10 by the end of the time that it's sitting in that account, because it's been earning interest that whole time. Now, the $100 that was deposited into the account in February has March, April, May, and June to accrue interest. So it's also accruing interest. It gets 1% per month, but it doesn't accrue interest for as long. So it's 1%, but it only gets to accrue that interest for 4 months. So $100, 100% of that $100 plus 1% interest for 4 months is $104.06 by the time it gets to July. For March, $100 is deposited. It's going to earn interest for April, May, and June. So 3 months that it will accrue interest for. And it will become $103.03. The $100 that's deposited in April will accrue interest in May and June. So it's going to accrue that 1% interest for 2 months. It will become $102.01. The $100 deposited in May will accrue interest for 1 month, and it will become $101. And then the $100 deposited in June will not accrue interest at all. And so that will just stay $100 because it's not going to add any interest. Okay, so if we add up all of those amounts that were saved, that will tell us how much money is in the account at the end of the 6 months, or at the very first day of July. and it's $615.20. So 600 of those dollars were deposited into the account. $15.20 were interest that was accrued. All right. Here is a formula for working with an ordinary annuity. It says that assume that you are making N regular payments. R is the amount of the regular payment into the annuity. So this is different than the principal amount because usually we're talking about one amount that is put into an account and just sits there. Here we're talking about the size of the payments that we're making regularly. So these are payments. And then the rest of the values in here are kind of what we would expect them to be. So compounded M times per year. So if it's compounded monthly, it's a 12, or if it's compounded daily, it would be 365, or if it's compounded quarterly, it would be 4. R is still the interest rate, and then N is the number of payments, the number of compounding periods that happen in that year. So if it's compounded monthly for 4 years, you would do 12 times 4. And then A is the future value or future amount of the annuity after all of those periods. Okay, so here's an example using this formula. It says, suppose that Christian has a habit of buying a tall cafe latte that costs $1.95 at Starbucks 6 days a week. If instead he put his money into an ordinary annuity, how much would he have in his account if he deposits his monthly savings in the annuity for 15 years? Assume that the annual rate paid on the annuity is 3%. So we need to calculate how much he's going to pay into the annuity per month. We can see that the rate is 3%. And since it's monthly savings, we're going to say that it's compounded monthly. So let's go ahead and figure out what his monthly rate would be. It would be $1.95 per latte, 6 days a week, so times 6. So this is for 1 week. $11.70 per week. And then there are 4 weeks in a month. $46.80 per month. Okay, so instead of buying a latte each month, if he was taking that money and making a payment into an annuity each month, that would be $46.80 being paid into the annuity. So that's being paid right there. And then we have 1 plus 3% compounded monthly. Over here, 3% compounded monthly. This would be monthly for 15 years. So we're going to say 12 times 15 up there. And then there's a minus 1. Now, this formula is pretty complicated to plug in on a calculator, especially if you don't have a graphing calculator like this. So I'm going to go ahead and show you how to plug it in, but then when we're done with this, we're going to use our TVM solver to do problems like this in the future. So 4680, I'm typing that first, and then I'm going to type the parentheses because that's what the problem has next. But this has a fraction, so I'm going to hit... I'm going to get a fraction on my calculator screen, and the way that I do that is I hit this green button right here and then this gray button right here. And the first option allows me to type in a fraction. Okay, so I'm going to have another set of parentheses here, these ones. 1 plus 0.03 divided by 12. So there's those parentheses, raised to an exponent, so raised to 12 times 15, and then I want to subtract 1 off. So I'm going to do a right arrow to get out of that, subtract 1, okay? And then down at the bottom, I have to do 0.03 divided by 12. So, and then all the way at the right, parenthesis around that. So this looks like this. As you can imagine, there's, different places where you could make mistakes. This is pretty complicated to plug in. So what we're going to do is we're going to do this exact same problem, but we're going to use the TVM solver. So I didn't link it on the assignment this time, but it is still linked on Moodle, so make sure that you go back and use the TVM solver again. So we're going to plug all this information into the TVM solver and see how much easier it is when you use your calculator or use the solver to calculate this. So we have N is the number of monthly payments we're going to make. We know that's 12 times 15. We have our interest rate, which was 3%. For our starting value or our present value, they didn't tell us that we're starting off by putting anything specific into the account. And so that starting value is a value of $0. All right, the payments that we are making each month is $46.80. And since these are payments that we're making, we're going to make them negative because I am paying it into the account. Okay. The future value of the account is what I'm solving for, so I'm going to put a question mark there. And then the compounding periods are monthly, so I'm going to put 12. All right, so let me go ahead and solve this in a much easier way. So I'm going to do 12 times 15, 3, 0, negative 4680. I don't know yet. 12 and 12. Okay, and then up here, I'm going to press the green button and then enter, and it's going to tell me $10,622.32. So I get the same answer, but it was much easier to type in. And then make sure that whenever you're using this method, using a TVM solver so you don't have to work with these formulas, that you write this down on your paper and tell me what you're plugging in for each thing in the TVM solver. All right, next we're going to look at sinking funds. A sinking fund is an account established for regular deposits, so again, payments, so that a fixed amount will be available in the future. So assume that you wish to save $1,800 in a sinking fund in 2 years. The account pays 6% compounded quarterly, and you will also make payments quarterly. What should be your quarterly payment? Okay, so the time period is 2 years. We have quarterly payments. So N is going to be 2 times 4, and then 4 and 4, compounded quarterly. The interest rate is 6%. The present value, we don't have anything that we're putting in the account to start with. The payment is what we're trying to find. We don't know what our quarterly payment should be. We do know that we want to have $1,800 at the end of the 2 years. Okay, so if you've plugged all this in, you can go ahead and hit solve for payment. I'm going to go ahead and do it on here. 2 times 4, 6, 0, I don't know yet, 1,800, 4, 4. Okay, the payment is what I want, so I'm going to hit the green button and then enter. So my payments would be $213.45. All right, last example. Suppose you have decided to save $1 million. Your plan is to put $200 away each month into an ordinary annuity that pays an annual interest rate of 8%. In how many years will you be able to say that you are a millionaire? All right, so it says that we're going to be putting away $200 each month. And so that means that our compounding period is going to be months. And it also means that what we're solving for up here is the number of months. So this number could be pretty large because it's going to be years multiplied by months. That's going to be a pretty big number. We have 8% interest. Present value, we're not starting the account with any specific amount of money. We're making $200 payments, so negative $200 that we're putting in each month. And then the future value is $1 million. And this is what we're trying to solve for. And this is going to be a lot of months. 12 months is a year, 24 months is 2 years, 36 months is 3 years, and it's probably going to be a lot of years of making $200 payments for this to become $1 million. So just keep in mind that as we solve this one. All right, so if you've put it in the TVM solver, you can go ahead and say solve for M. If you're putting it in the calculator TVM solver, then we can go ahead and plug these in. We have 8, 0, negative 200, 1 million, 12, and 12. And we're going to go up here and solve for N. 532 months. So that makes sense. It's a lot of years. 532.18. And we're going to divide this by 12 months per year to just figure out how many years this is. So that's how many months. We want to know how many years that is because that's a lot of months. 44 years. This is in 44.34 years. That's how long it would take you to become a millionaire by putting $200 away each month and making 8% in your annual interest rate.